So now let us talk about proper and improper fractions and what they really mean and how to convert one to the other. So a proper fraction, you have a numerator and denominator is when the top numerator, this is a less than symbol, if you ever see that, less than the denominator. And this will give you a number less than 1 in decimal form. So it could be 0 point, whatever it is. So, the easiest thing to deal with is fractions of 10. So 9 out of 10 is 0 0.9. Always be less than 1. Improper fraction. So when you have the numerator is greater than the denominator. So it'll be greater than 1. So could be all sorts of things. Let's get into a specific one. So 13 over 10. So that's essentially, if you punch down your calculator, you will get 1.3. I mean, you didn't have to use this example. You can get, improper fractions like 27.5 or whatever it is. Like you can use 52 over 3, for example. As long as there's our criterion, top is greater than the bottom, then you have an improper fraction. Because it doesn't look nice when we convert it to percentage. So why do we say this is proper? One way of looking at it is, so for example, 9 over 10, 0 0.9. We multiply that by 100%. It has a nice look to it. So 90%. 90% of people are this, 90% of people are that, 90% of objects are this, 90% objects are that. Well, when we're doing with improper fraction, so 13 over 10, 1.3, 130%. And we'll get into the meaning of, what things over 100% looks like. But just remember from the last video, you can always convert to percentage. I didn't do anything special. This is just an extra. So, I mean, you can completely remove this from, this video, but kind of want to reinforce the idea that, fractions, decimals, and percentage are really the same thing. So let's start out with a simple improper fraction like 13 over 3. Now, you could imagine this, the meaning of this, like the previous video, we discussed boxes of 3. And then you just, so coloring in 13 colors. But you can see right now we're going to need additional boxes. So 3, 6, 9, 12, 15. This is kind of a pictorial description of what we're really looking at. So we got 13 drawn in. So 3, 6, 9, 12, 13. So what do we have? So we have 4 boxes filled, and 1 out of 3 filled. And that's essentially what the answer means, or the answer, what it really produces. 13 over 3 is 4 and 1/3. Now, this is just a graphical representation. You can't really do this, when you have something very large. You're not going to draw boxes and color them in. We want to kind of have a more professional framework of how to deal with these things. Kind of general, when you can generalize something, it becomes really easy to apply it to any situation, so you're right. So let's just say you have something like this, and if you wanted to know, like, what that really means, is, in number wise, that's really 4. You keep the same whole number, and this is essentially telling you what's after the decimal. So this is, if you punch in to calculate 1 over 3, it's 0.33333. So this is just, 33333, and again, getting a percentage of that times 100%, that's really 433%. Still means the same thing. So if you started out with a mixed, and this is called a mixed fraction. You started out with a mixed fraction. So you have 3 numbers, a and b over c. Now, to convert that to improper, if you ever wanted to do that, it's kind of easier to start this way, kind of have a general formula for it, or an understanding for it, and then go the other way around. So to get that, you'll just do a times c, and I'll put things in brackets that go first. So you order them first. So first you'll do a times c, so 4 times 3, for example, and then you'll add the top part. And another way of graphically looking at this is you wanted to see how many are colored. When you have something over something else, you want to see how many are colored. Now, how do we get that? So, A was our 4, for example. So we got 4 boxes and 3 colors per box. So, 4 times 3. So be the top, let's just say 4 times 3. And then you added whatever was left over because you want to know how many total are colored. So, plus 1. Then the denominator essentially just stays the same. So in the previous example, 3. Now what's 4 times 3? That's 12 plus 1 over 3. That's 13 over 3. So you just kind of have to remember this step. If you don't want to remember this formula, imagine it like boxes. Okay, we have, so 4 and 1/3. We have boxes that are made up of 3 slots, okay? 4 of them are filled. So you have 4 full boxes, 1, 2, 3, 4. And then the last one, just 1/3 of it is filled. So 1 out of 3 are filled. Now, if you want to go the other way, so it's 13 over 3, and you want to go to a mixed fraction, like this right here. So what you'll do is, you'll punch in your calculator, 13 divided by 3, and that gives you 4.333. So first we'll extract this whole number. So, that's really, so 4. So we want it to look like that. So 4, and what do you have left over? Well, if you have 4 filled, so how many colors have you used so far? So 4 times 3, because each box is composed of 3 slots. 12. So far, you've accounted for 12. But you know that there's 13, so there has to be 1 left over. So then you do whatever's remaining. 13 minus how many you already accounted for. That leaves 1. And that's your final answer right there. So kind of messy over there. 4 and 1/3. So let's just do another example.